Hello, ladies and gentlemen. If you could title in your notebook, please, for 8-5 Day 2. We are going to talk about some differences of squares today. And two things we're going to be working through in this lesson are both factoring and as well as solving some difference of squares equations. So want to just work through a couple more factoring examples with you as well as solving. All right, so here we go. First, a little review, just to make sure we're good to go with all things differences of two squares. First one in your notebook here for a little reminder of factoring these. If you have 25a squared minus 36b squared. Once again, you're looking for, is it a difference? And are both those terms perfect squares? Which they are. So you can square root both terms and then write them as their square root positives and negatives for that factored form. So it would be 5a plus 6b times 5a minus 6b. And then it's always a question, are there any other perfect squares that are differences of two squares left to factor in this case? No, there's not, so this one is done. Next one in your notebook, 5x cubed minus 20x. Hopefully noticing that neither of these numbers are perfect squares. So in order to be able to factor this one, we need to get out the greatest common factor. Greatest common factor here is 5, and they both also share an x. So we're going to factor out that 5x, and then if we do that, oops, don't need that yet. If we factor out the 5x, we're left with an x squared minus 4. And then check it out. We now have a difference of two perfect squares, so we can use that property we talked about yesterday and square root both of those terms. Drop down your 5x as your greatest common factor, and then x plus 2 times x minus 2. Once again, I think we're done here. We don't have any other perfect squares left to factor, so that would be your final answer for number 2. Last one I want to work through. Number 3 says y to the 4th minus 16. Just a reminder that if you have an exponent that is an even exponent, that is always a perfect square. So both these are perfect squares. We're going to square root right away. There is no greatest common factor. When we do that, we get y squared plus 4 times y squared minus 4. And then while we're thinking, ooh, we're done, we factored it all the way. Actually, we're not, because this one is still a difference of two squares. So we need to break this one down one more time and get y plus 2 times y minus 2. Don't forget to bring down that y squared plus 4 as part of your final answer. This would be factored all the way. Remember, you cannot factor a sum of two perfect squares. So this one right here is not factorable. You leave it alone. You're only looking for those differences of two perfect squares. So hopefully that helps with a little review. Now, let's get into some new stuff. New stuff for today is you're going to see something that looks a little bit more like this. This 6x cubed plus 30x squared minus 24x minus 120. So check it out. Hopefully this is bringing back good memories of, okay, well, if I have to factor this, this is 4 terms here. None of them are like terms, but also looking for the fact, well, for sure, to make life a little bit easier, I always want to ask myself, is there a greatest common factor that I could get out of all 4 of those? And actually, if I look at these, well, yeah, 6. I could get a 6. I cannot get an x out of all of them, so I'm just going to factor out that greatest common factor of 6. What's left over would be x cubed plus 5x squared minus, if I factor the 6 out of negative 24x, that should be negative 4x minus 20. Awesome. All right, we got to keep factoring. Once again, you've got 4 terms here inside that parenthesis. Hopefully you remember that in order to factor something with 4 terms, we factor by grouping. So if we group the first 2 terms, boom, boom, group the second 2 terms, being very careful to make sure that that negative goes with the 4. So I'm going to do plus a negative 4. Boom, boom. Then we need to make sure we factor out the greatest common factor from both those terms in each of the parentheses. So I'm going to keep the 6. X cubed and 5x squared both share a x squared. If I factor an x squared out of both of those, I'm left with x plus 5. Negative 4x and negative 20. Those both share a greatest common factor of negative 4. And if I factor a negative 4 out of both of those, I'm left with x plus 5. Check it out. We're kind of doing our happy dance now because we were able to get out that greatest common factor of x plus 5. Both of those are exactly the same. So I'm going to drop down my 6. I'm going to factor out the x plus 5. Gone, gone. And then what's left over goes in that last parenthesis, so that x squared minus 4. And while you're like, whew, that was a lot. Greatest common factor, factor by grouping. You're actually not done, ladies and gentlemen, because if you look at all three of these factors, this one hopefully is a red flag. It's a difference of two perfect squares. So we need to factor this one more time. We're going to keep the 6. We're going to keep the x plus 5. And then the factored form of that difference of two squares would be x plus 2 times x minus 2. Now I think we got it. We factored that all the way. This is what I'd be looking for on your quiz coming up next week. If you were to factor by grouping, I guess first greatest common factor, then factor by grouping, and then lastly, apply that rule of differences of squares. Awesome. All right, next thing we got to do. We've got 2 examples left. I just wanted to try a couple solving quadratic equations here. This first one, notice you've got that q squared minus 4 all over 25 equals 0. If we want to solve this equation, hopefully the first thing that you're thinking in your brain is that equation has to be set equal to 0. In order to set this equal, or it is already set equal to 0, so we're good to go. So now we have to, the only way to solve a quadratic is to have it in factored form. Well, check it out. It's a difference of 2 squares. So I'm going to square root. There's that super cool rule about perfect squares in a fraction. You can actually break that square root and do the square root of both the numerator and the denominator. So if I put this into factored form, I would see q plus square root of 4 over the square root of 25 would be 2/5, and q minus 2/5. Once you've got it in factored form, then you can break it, set both those factors equal to 0. So q plus 2/5 is equal to 0, and q minus 2/5 is equal to 0. Then this just is a one-step equation. You'd have to subtract this away. So one solution is negative 2/5. You could also add the 2/5 to the other side. The other solution would then be positive 2/5. You might see in my answer key that I write this answer kind of smushed together since it's the same answer, both the positive and the negative. So you might see my answer key look something like this, the positive and negative 2/5. So just a heads up there if you see that in the answer key. But you could also just give me both answers individually. Both mean the same thing. Awesome. All right, last one. Last example here, we want to, same thing, solve this quadratic equation. What's A, not a quadratic. Look at that, you've got a cube going on in there. B, problem, it's not set equal to 0. So I would argue your first step should be to subtract that 50x and set this quadratic equal to 0, or set this, I guess, 18x cubed, this cubic, minus 50x equal to 0. And then in order to make it a quadratic equation, I guess ideally, I'd want a difference of 2 squares. Neither of these are perfect squares, but hopefully you do notice that there's a greatest common factor that both of them share. And so I can for sure get a 2 out of both those coefficients, and I can also factor out an x. If I do that, I factor a 2x out of 18x cubed, I'm left with 9x squared. If I factor a 2x out of negative 50x, I'm left with negative 25, which is so awesome because, check it out, you've got the difference now of 2 perfect squares, 9x squared and 25 are perfect squares. So I'm going to square root both of those. use my difference of two squares rules, which means I've got 3x plus 5 times 3x minus 5. Once again, my equation is still equal to 0, but now that it's in a product of all of my factors, I can break this. And here's the deal. You've actually got 3 factors. All 3 of those have variables, so you need to set them all equal to 0. So 2x equal to 0, 3x plus 5 equal to 0, and 3x minus 5 equal to 0. Quick solving here, if we divided by 2, 0 divided by 2 is still 0, so that's one of our solutions. If we take away 5 and divide by 3, looks like another solution will be negative 5/3. Very similar, but we've got the opposite here. If I add 5 and then divide by 3, your other solution should be 5/3. So there are actually 3 solutions to this equation. I believe that has to do with the fact that if we go back to the original equation, this actually wasn't to the power of 2, but it was to the power of 3. So that has something to do with how many solutions we have. So since it was to the power of 3, we actually have 3 solutions for this one. Once again, you could smush this together. You could say that the answer for x is equal to 0 and also positive and negative 5/3. So just in case you see that on my answer key, you know what that means. All right, well, I hope this helps with your lesson today. The homework I'd like you to try for the rest of the work time in class is 36 through 43 all on page 501 and 46 through 54, just the evens. Please make sure you get this done for Friday because Friday is our final review day, so you can ask me some good questions. If you have extra time in class, please feel free to study your vocab because you have a vocabulary quiz tomorrow. All right. Look forward to seeing you guys. Enjoy your work time. Get a lot done. We'll see you tomorrow. Bye-bye.